Hello all, myself Sambasiva Rao, working as Assistant Professor in the Department of Civil Engineering at VNR VJEC. Today we are going to discuss the topic overtaking side distance as a part of highway geometric design for civil engineers. So this is the definition regarding to overtaking side distance. So the definition is it is self-explanative. The minimum side distance, the minimum distance which is available on site. The definition is the minimum side distance or the distance which is available on site for the driver for performing the overtaking operation. So that is what the overtaking side distance. So you can see the definition, the minimum side distance open to the vision of the driver or the glance of the driver of a vehicle intended to overtake the slow moving vehicle. So what is the need for overtaking the vehicle is nothing but you are traveling at a higher speed. So you need to overtake the vehicle in front of you which is traveling at a slow speed. Okay, that to against the traffic which is moving in the opposite direction. So here, so you can see the directions of the vehicles which are traveling. So this is my green vehicle which is nothing but this is my vehicle A which is traveling at higher speed. So I'll go for the designation of the vehicles. So this is nothing but you don't think there are so many vehicles over here. So the vehicle with green color is vehicle A. That is nothing but high speed moving vehicle, and the vehicle with yellow color is slow moving vehicle, and the vehicle in red color is opposite vehicle. So here the position of the vehicle A, this is the position of the vehicle A at A1. So this will be A1, and this is the position of the vehicle at A2, the vehicle A at A2, and this is the position of the vehicle B at in an instant of B1, and this is the position of the vehicle B at an instant of B2. And similarly, this is the position of the vehicle C1, okay, in the opposite direction, and this is the position of the vehicle C2 at. So these are the different positions of the vehicles. Okay, so vehicle C is moving in the opposite direction, and the vehicle A and B are moving towards right direction. Okay, so here I'll go for the nomenclature. Vehicle A is nothing but high speed moving vehicle, and vehicle B is nothing but slow speed moving vehicle. Vehicle C is nothing but opposite vehicle. So this nomenclature is very, very important. At the same time, vehicle A is also called as overtaking vehicle, because this is nothing but this is a vehicle which is moving at higher speed. So it has to overtake the slow moving vehicle which is nothing but the vehicle B. And B is nothing but slow moving vehicle. This is said to be the overtaken vehicle. So these are the two different names which we use for vehicle A and vehicle B respectively. Overtaking vehicle and overtaken vehicle. And vehicle C is an opposite vehicle. So we don't have any other name for the vehicle C. So here you have to understand what are the different positions of the vehicles. So when the vehicle is at A1, we are not bothered about the vehicle position of vehicle C and vehicle B. Okay. So this is just before overtaking. So the vehicle A has to travel with the same speed as that of vehicle A. Vehicle A has to travel with the same speed of that vehicle B. So that is why, so this is the A1 and A2 before overtaking operation. That is, I am telling just before overtaking, it will travel behind the vehicle B for a small time which is said to be the reaction time. This is also called as reaction time small t. It is going to travel behind that vehicle B for fraction of seconds or 1 or 2 seconds. So the IRC code recommends the reaction time for the overtaking operation is nothing but 2 seconds. So this is going to travel behind the vehicle B at a speed of VB, not at the speed of V. Okay, that vehicle A is going to travel with the same speed as that of vehicle B because it is going to follow for some point of time. So that is what regarding the vehicle. And the position of the vehicle A just before overtaking, just at the start of overtaking operation. Okay, so at the start of overtaking, vehicle A is at A2, and vehicle B is at B1, and vehicle C is at C1. Okay, that is what you have to remember. By that time, just before overtaking, at the start of overtaking, vehicle B is at B1, and vehicle A is at A2, and vehicle C is at C1. Okay, at the end of overtaking, after the completion of overtaking, by the time of completion of overtaking, vehicle A will be coming along this path and will be updating to the position A3. I repeat, vehicle A will be shifting its position, overtaking the vehicle coming onto the next lane, okay, and will be shifting to the same lane at position A3. In the meanwhile, vehicle B is only traveling from B1 to B2. So in this entire overtaking operation, vehicle C is going to move from C1 to C2. So the time in which this entire operation is happening, that is said to be the overtaking time, which is represented as capital T. During the entire overtaking reaction time, vehicle A is moving from A2 to A3, and vehicle B is moving from B1 to B2, and vehicle C is moving from C1 to C2. And just before overtaking and after overtaking, we have to maintain some distance, the spacing between vehicle B and vehicle A. So this is represented as S. So you can represent it as S1 if required, if both S1 and S2 are different. So that is what the spacing. We cannot keep the vehicles back to back just before the overtaking or after the overtaking. So these are the terminologies which you need to be familiar while discussing the overtaking side distance. Okay. Next, I'm going to write the formulas for different distances. So this is the distance D1, which is nothing but the distance traveled by the vehicle A before the overtaking operation. That is nothing but it is going to travel for some point of time, that is D1. And the distance D2 is nothing but the entire distance traveled by the vehicle A during the entire overtaking reaction time. And this is the distance D3, which is nothing but the distance traveled by the vehicle C during the entire overtaking time. Okay, so and the distance traveled by the vehicle B during the entire overtaking time is only B1 to B2, so which is represented as B. Okay, so now I have to calculate the value of capital T. Here very important, I am very much interested to calculate what is the overtaking time capital T. Okay, so for which I have to write the equations. So from this figure you can see that D2 is nothing but S1 plus B, that is nothing but the distance traveled by the vehicle B during the overtaking time, and at the same time S2. These are the spacings before and after the overtaking operation. Okay, and these are regarding corresponding to the vehicle B. Okay, and also vehicle A is accelerating from VB to some speed. It is going to increase its speed from when compared to VB. It is going to accelerate. So the equations of the motion, the second equation of the motion, which is nothing but S is equal to ut plus half at square, which is nothing but the vehicle which is traveling initially at u speed is going to accelerate with acceleration A, and it is traveling for t time. Okay, if this is small t, this also will be small t. So this is the equation of the motion. So we are going to write the equation for vehicle A, because the vehicle A is traveling at a speed of VB. Okay, and it is going to accelerate, okay, with some acceleration A, and it will be traveling for some time t. That time is nothing but overtaken time, so which is nothing but capital T. So I am going to equate that to, okay, D2 is also equivalent to, okay, ut, which is nothing but VB, that is nothing but the speed of the vehicle A, but of course it is equivalent to that speed of the vehicle B just before overtaking or till the completion of overtaking. So VB into capital T, it is traveling for capital T time, plus half into A into T square, which is nothing but that is equivalent to S1 plus S2 plus B. So S1 plus S2 plus B. If you look into the back slide, so B is nothing but the distance traveled by the vehicle from B1 to B2. So as the vehicle B is moving with the uniform speed, so the equation of for the distance is equal to, as we know that speed is equal to distance by time, so therefore distance is equal to speed into time. The speed at which the vehicle B is traveling is VB, so therefore that is nothing but VB, and the time for which it is traveling is nothing but entire overtaking time. So this is equivalent to this. So as per this equation, both are equal. Okay, so therefore this VB into T, this VB into T are going to get cancel each other. So we are left out with S1 plus S2 is equal to half A T square. S1 plus S2 is equal to half A T square. So therefore 2 times of S1 plus S2 is equal to A T square, and T square is equal to, okay, 2 of S1 plus S2 divided by A. If I want to get the value of T, I'll shift the root over here. So this is nothing but capital T, that is nothing but overtaken time, is equal to under root of 2 of S1 plus S2 by A. A is nothing but the acceleration of the high speed moving vehicle. So this, if you take T, S1 is equal to S2 is equal to S, so therefore this equation is going to become T is equal to under root of 4S by A. So this is what the derivation for overtaken time. So this is very, very important. So next. So this is the table which is a gist of all the distances traveled by the different vehicles. So this first is nothing but the vehicle A. So this is a green color, the vehicle A, and this is also the green color, vehicle A, and this is the vehicle B, which is in yellow color. Okay, and this is the vehicle C, which is in red color. Okay, so the distance traveled by the vehicle overtaking vehicle A during reaction time, that is nothing but small t. The time for which it is traveling is nothing but small t. The distance traveled by the overtaking vehicle during overtaking time, entire time, this is the reaction time small t, and this is nothing but capital T. The similar way, the distance traveled by the overtaken vehicle, I told you that vehicle B is nothing but the small vehicle, slow moving vehicle. So for which we call the vehicle as overtaken vehicle. So this is also the time taken is nothing but the time for which it is going to travel is capital T. And the distance traveled by the oncoming opposing vehicle C during the overtaking time. So this is nothing but it is also capital T. So therefore the position for this it is traveling is nothing but A1 to A2. That is nothing but before the overtaking operation. Okay, we are very much interested only the A2 to A3, the time for which it is traveling during the overtaking time, and the vehicle B is traveling from B1 to B2 during the overtaking time, and the vehicle C is moving from C1 to C2 during the overtaking time. So the speeds are also very, very important here. Even though the speed of the overtaking vehicle is given in the question or in the problem, that speed should not be taken for vehicle A. Even though the name is overtaking vehicle, but it is going to travel or start with the speed of that vehicle B. After overtaking, it will start with design speed. Okay, so that is what it is going to travel, vehicle A or vehicle B. Both the vehicles are going to travel. A and B are going to travel with the only the speed of which is equivalent to the vehicle speed of the vehicle B. Okay, only the vehicle C, which is coming in the opposite direction, is going to travel with small v, which is nothing but the design speed, which is nothing but the design speed. So which is nothing but the design speed over here. Okay, and wherever I am writing here small v's, okay, this is nothing but meters per second. The units for the speed is nothing but meters per second. Wherever the question is given, it is mostly given in capital V, which is nothing but kilometers per hour. So this is the nomenclature, the terminology which is involved over here. So you can see the derivations over here. D1 is nothing but the distance traveled. So the distance traveled by the vehicle A during the reaction time. So that is nothing but the speed at which it is traveling is nothing but VB. So therefore D is equal to VB into reaction time small t. Okay, and this is a D2. Already we have seen in the previous slide, S1 plus S2 plus B or B plus 2S, where S1 is equal to S2 is equal to S. And S is equal to, here it is very, very important, S is also the spacing between, this is what the spacing between vehicle A and vehicle B. The clearance, the exact separation between both of them is equal to 0.7 VB, which is nothing but the distance is being equivalent to, okay, the time of 0.7 seconds where the vehicle B is traveling or the vehicle A is traveling for a speed of 0.7 seconds. So this is nothing but time 0.7 seconds multiplied by speed, which is nothing but the distance. So the distance we have to give a spacing of 0.7 VB plus half the length of the vehicle L by 2, half the length of the vehicle L by 2. So that is nothing but we have to give the spacing of L on either side. If you take front to front, it will be L, or if you take center to center of the vehicle, even then it is L by 2 plus L by 2. That is nothing but the value, the formula for S. S is equal to 0.7 VB plus L. If S is given directly in the question, you can adopt the same value. You need not to do this calculation. But whereas if S is not given, you have to adopt this value 0.7 VB, which is plus length of the vehicle. So once after completion, so this is the final overtaking distance, OSD, overtaking side distance, which is nothing but OSD is equal to D1 plus D2 plus D3. So this is the final value what you are going to get. And you have to remember so far the discussion what we made is corresponding to the two-way traffic. It is nothing but two-lane, it is two-lane carriageway, and the traffic is also two-way traffic. So that is why we are going to have the vehicle in opposite direction, which is nothing but the vehicle C. But whereas if the vehicle in the opposite direction is absent, which is nothing but in the absence of the vehicle C, we are going to have only the distances D1 and D2. Because D3 is the distance contributed by the vehicle C, which is moving in the opposite direction. It is taken as to be 0 because there is no vehicle in the opposite direction. So therefore, the distance or the OSD is going to become as OSD is equal to D1 plus D2 in terms of two-lane that should be definitely 2-lane road, and in the absence of two-way traffic, that is nothing but one-way traffic. The traffic is one-way traffic, so both lanes moving towards right. So we have only vehicles A and B, so for which we are going to have D1 plus D2. And here, whenever you don't have the chance of providing, we don't have the chance of overtaking along the length of the road, okay, particularly in terms of intermediate carriageways, we have to provide some overtaking zones for the purpose of overtaking in terms of the high speed moving vehicles. So that zone will be something like this. So there is a zone like this. So the minimum length of the overtaking zone, minimum, this should be provided at any cost in terms of the overtaking zone. So this value will be equivalent to OSD. You have to calculate the OSD from the given data, which is nothing but D1 plus D2 plus D3. So once you get this data, you have to provide 3 times of that for which is nothing but the minimum overtaking zone for intermediate carriageways. Okay, and desirable value will be, at least you have to provide extra 1 OSD on this side. So this is nothing but OSD, and also you have to provide 1 OSD on this side. So this total value is going to become 5 times of OSD. So this is the desirable length of the overtaking zone, and this is the 3 times of OSD is the minimum length of the overtaking zone. And again the same thing, D3 will be 0 in terms of one-way traffic because you don't have the vehicle C. So therefore D3 will become 0 over here, and D3 will become 0 here in this case. Okay, but these both are corresponding to desirable, which is nothing but 5 times of OSD. So this is nothing but OSD. Okay, so these two are corresponding to 5 times of OSD, and these two are corresponding to 3 times of OSD. So these are the different values you need to remember for in terms of overtaking zones. Okay, now we look into this small problem. Calculate the OSD on a national highway for a design speed of 100 kmph, given that the acceleration of the overtaking vehicle is given as 0.92 meters per second square. So here only one speed is given. That speed is the default. We have to take the speed as design speed, which is nothing but it has given in kilometers per hour, which is nothing but capital V, which is nothing but 100 kmph. So we have derived the formulas each and everything in terms of small v's, which is nothing but meters per second. So we have to go for the conversion of the speeds. I think you are familiar with the conversion of this. So therefore capital V will become small v if you divide this 100 kmph divided by 3.6. Okay, so that is very easy. You substitute the value of kilometers 1000 meters, divide by second as 1 hour as kilometer per hour, where 1 hour is equal to 60 minutes multiplied by 60 seconds. So you'll get the value as 30 divided by 3.6, which is nothing but somewhere around 27.77 meters per second. So now this is nothing but small v, and again small v is nothing but design speed in terms of meters per second. So only the vehicle which is traveling at the design speed is nothing but vehicle C, not vehicle A and vehicle B. Okay, so this is the speed of the vehicle C, which is the design speed of the vehicle, 27.77 meters per second. And we don't have the relation directly between the speed of the vehicle B and the speed V in meters per second. Of course, we have the conversion or the relation, which is nothing but VB is equal to V minus 16 kmph. If we deduct a 16 kmph for the design from the design speed, we are going to get the speed of the vehicle A or vehicle B, which is nothing but VB. So from this we are going to get VB is equal to 100 minus 16, which is nothing but 84 kmph. That too, of course, in kilometer per hour. Again we need to get this value in meters per second. Therefore VB is equal to 84. Once you convert, that value will become 23.33 meters per second. So these are the speeds. Of course, these are only the two speeds which we are going to encounter in the problem solving of OSD. So once after we get the values of V and VB, so we are going to get the value of D1. D1 is nothing but VB, that is nothing but, even though it is a vehicle A which is traveling during the reaction time of the time, so it is taken as 2 seconds, which is fixed in terms of OSD. Okay, and the speed is nothing but VB. So therefore that is nothing but 23.33 into 2, which is nothing but 46.66 meters. Okay, so distance multiplied by time, meters. Similarly, we have to calculate D2. So for which D2, we need to calculate what is the overtaking time, capital T. So therefore capital T, already we are familiar with the capital T. We already looked into the derivation, which is nothing but 4S by A. Again you have to look at the formula for S, which is nothing but S is equal to 0.7 VB plus L. Here L is to be taken, so let us assume this to be 6 or 6.1 meters. L is nothing but, I'm going to write over here, L is equal to 6.1 meters. So therefore you substitute the value of over here. So 0.7 into VB is nothing but 23.33 plus 6.1. We'll get the S value to be somewhere around 22.43 meters. 22.43 meters. So this is the value of S in meters. So therefore if you substitute the value of D2, which is nothing but 2 times of S plus B. So 2 into S is nothing but 22.43 plus B is nothing but VB into T. So therefore VB is nothing but 23.33 into capital T. So from this, if you calculate the value of, if you substitute the value of substitute the value of S over here, and the acceleration is given as 0.92. If you substitute the values both, you are going to get the value somewhere around 9.51 seconds. 9.51 seconds. So this is overtaking time. So capital T. So if you want to substitute that, you are going to get the value of capital T. So 9.5 seconds. 9.5 seconds. If you get this, you are going to get the value of D2. Again, D2 here, in this case, it will be equivalent to 266.73 meters. Again, similarly, you have to calculate D3. Here, we are not going to have the speed VB. We are going to have the speed V, which is nothing but the design speed of the vehicle in meters per second, which is nothing but 27.77 meters per second in this case, multiplied by T. Capital T is nothing but 9.51 seconds. So therefore, we are going to get the value of 264.09 meters. So therefore, we are going to have the total OSD. OSD is equal to D1 plus D2 plus D3, which is nothing but we are going to have 577.48 meters. So this is the overtaking side distance for a two-way traffic. Here nothing is mentioned. You have to calculate for the full length, which is nothing but we have to assume that to be a two-lane road with two-way traffic. Only we have to reduce the D3 value when it has been mentioned that there is no traffic in the opposite direction, or that is nothing but one-way traffic. So otherwise the value of OSD remains as D1 plus D2 plus D3. So similarly, if you want to calculate the length of overtaking zones, minimum length, so you have to multiply this with 3 times of OSD, and similarly you can multiply this with 5 times of OSD in order to get the desirable length of overtaking side distance. So next we'll look into one more problem, the speed of overtaking and overtaken. So this is nothing but the speeds of overtaking and overtaken vehicles are given 70 and 40 kmph, so respectively, on two-way traffic. If the acceleration of overtaking vehicle is 3.6 kilometers per hour per second, here you have to look into that. Okay, the acceleration is given to be a bit different. Okay, it is not given directly in meters per second square. The acceleration units are nothing but meters per second square, but here the value is given as 3.6 kmph per second. Kmph, if you convert that, it will get speed, that is nothing but meters per second. It will become as meters per second square. So the speeds of the overtaking vehicle, so that is nothing but overtaking vehicle. Even though vehicle B is your overtaking vehicle, but you shouldn't take the overtaking speed of the vehicle as 70. You should take the vehicle C, capital design speed of the vehicle, which is nothing but corresponding to the vehicle C only. So this 70 kmph is corresponding to the speed of the vehicle C. So therefore here capital V is equal to 70 kmph. So you convert that into V, which is nothing but 70 divided by 3.6. You get the value of small v, and similarly you need not to subtract 16 from this, because already the speed of the overtaken vehicle is given, which is nothing but the speed of the vehicle A and B. So therefore capital VB is given, which is nothing but 40 kmph. Okay, from this you have to convert this VB is equal to directly, there is no subtraction involved over here. So 40 divided by 3.6, you will end up with the value of VB. So once you get the value of V and VB, again you have to calculate D1. D1 is equal to VB into T, reaction time. Of course, if it is not mentioned, default you have to take it to be 2 seconds. So you convert this value into meters per second and you substitute the value, you will get the value of D1. Okay, and D2 is only a different question. Okay, the calculation remains constant. Okay, but only the condition is they have given two different speeds. If only one speed is given, that too they are mentioning it as a design speed, that will be default equivalent to the speed of the vehicle C. If two speeds are given, higher speed will be equivalent to that speed of the vehicle C, and lower speed, lesser value speed will be equivalent to the speed of the vehicle A and B. Okay, so therefore D2 is equal to 2S plus B. 2S, you have to calculate again the S value, where S is equal to 0.7 times of VB plus L. Again you have to assume the value of L when and where the values are not given. You have to note the write the statement, assume the value of L, length of the vehicle, to be 6 meters. So from this, again you know the value of B, which is nothing but VB into capital T. Of course, again, you have to calculate what is the value of capital T, which is nothing but 4S by A. You substitute the value of S over here, and acceleration. Here, I'll just go for conversion of the acceleration. A is given as 3.6 kmph per second. This 3.6 again divided by 3.6 will become meter per second, whole per second. So, which is nothing but 1 meter per second square. So that is what simply he wanted to give as 1 meter per second square as the acceleration, but he wanted to confuse you by giving some different value so that you can adapt easily. Seeing that 3.6 acceleration, you have seen the value acceleration, so directly you can adopt the value of 3.6, but you also have to look at the units very carefully. Okay, so after that you are done with D2 as you have got the value of capital T here, and similarly you have to take the value of D3, which is nothing but V here, which means nothing but 70 divided by 3.6. You substitute the value of V over here into multiplied by capital T, you are going to get the value of D3. Once you get the values of all D1, D2, D3, you have to add all of them, D1 plus D2 plus D3. Again, condition is it is a two-lane, two-way traffic because it is not mentioned. Okay, so that is what OSD. So that is what they are asking for the question 1, A question, and they are also asking minimum, mention the minimum and desirable length of overtaking zones. You can work it out easily. Once you get the value of OSD, you multiply the value. Okay, minimum OSD zone length is equal to 3 times of, it is 3 times of OSD, and desirable OSD is equal to, so it is nothing but 5 times of OSD. That's it. This is the end of the discussion. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.